Hi guys, it's Mr. Like again. I got a really cool experiment you can do that involves this basketball and a tennis ball. Today we're going to see if we can't figure out how it works and how it relates to the cars going down the track. Watch this. A really cool way to look at collisions is using something called an air track. An air track is kind of like a skee ball table if you've ever played skee ball with the knocking the little discs around with the air coming up. What it does is it's basically a piece of metal that's got little holes in it. And when I turn on a reverse vacuum, it shoots air in there and then it keeps these cars kind of floating. Let's see what it looks like. So you can see this car moves with very little friction. We're kind of taking away a lot of the things that are in the collision and just looking at two things that are smacking together. Another great way to look at this is with billiard balls or pool balls because they smack together just like this as well. All right, let's see if we can make some predictions. What do you think is going to happen if I take this car, which is kind of the small car, and smash it in with the other small car? I'm going to make this car stationary, and this car is going to be moving. Let's find out. So here, the stationary car gets smashed in by the other car. This is very similar to what we're doing in our Hot Wheels track. What do you notice about how these things end up after the collision? Well, it seems like a lot of what was going on in the first car is now moving in the second car. We call that momentum. Momentum involves two things. Momentum involves how fast it's going and how big the object is. So in this case, the first car had all of the momentum as it comes moving in because it has speed. And in order to have momentum, you have to have speed. That momentum then gets transferred to the second car, and the second car continues to move. That way, the momentum that was moving this direction on the track continues to move that direction on the track. We have something called the law of conservation of momentum. Remember that word conserved. There it is again. That means it can't be created or destroyed. It has to go somewhere. So we would say that the first car has, we'll call it 1 unit of momentum. That 1 unit of momentum is going this direction along the track. And as they hit, that momentum gets transferred into this car. Did you see that with your cars when they were hitting down the track? Did your first car stop, or did your first car continue to move forward? I wonder why that is. Well, what if the cars are different masses? I said that momentum involves two things. It involves mass and the speed or velocity that you're going. So what if I have a really big car? Can we make a prediction about what's going to happen to the momentum if I hit a really big car into a smaller car? Let's find out. So you see, the momentum of the big car was moving in this direction. Let's call it 2 units of momentum this time. So you see, the big car was moving into hitting the smaller car. This might be more similar to what you had going on in your experiment. So let's call this, since it's a big car, we'll call it 2 units of momentum. It's got 2 things of momentum right here. And it's moving that way. That's before the collision. After the collision, we still have to have 2 units of momentum moving that way because momentum is conserved. It can't go anywhere. But it can be transferred from one thing to another. So if you look, the second car here went flying away. That may have had 1 unit of momentum, right? So there's one of the two. What happened to the other? Well, this big car continued to move, didn't it? It wasn't going as fast, so it didn't have as much momentum as it had before. The momentum, the 2 units of momentum, got switched. Some of it got switched into this car as it took off, and then the smaller car, the bigger car, went a lot slower. So momentum is also something that is conserved. We talk about energy being conserved. We also talk about momentum being conserved. In a collision, a lot of times we talk about momentum. Remember, momentum involves 2 things: how big you are and how fast you're moving. So we said that momentum is the property of an object that's moving, and it involves 2 things. It involves how big the object is, we call it its mass, and it involves how fast the object's moving, we call that its velocity. So what happens if I change one of these things? We said that momentum had to be conserved. I've got a car here, and I want to show you what happens when I change one of these variables. So this car, I'm going to be moving it along at a certain velocity. So if I move the car along, it has momentum. But then, as it's moving, I'm going to change its mass. I'm going to put a really heavy mass on it. And let's see what happens. We know that momentum has to be conserved. So what happens if I increase the mass? What's going to happen to the velocity? Let's find out.